questions 1 through 10 on the 2003 grade 12 AMC 12B. Which of the following is the same as this expression? So we've got 2 minus 4, 6 minus 8, 10 minus 12, and this lone 14 at the end. At the bottom, we've got 3 minus 6, 9 minus 12, 15 minus 8, and this lone 21. So at the top, we've got minus 2, minus 2, minus 2, plus 14. And at the bottom, we have minus 3, minus 3, minus 3, plus 21. And this becomes 14 minus 6 over 21 minus 9. And that's 8 over 12. And in lowest terms, that is 2 over 3. So number 1, the answer is C. Al gets the disease algebritis and must take 1 green pill and 1 pink pill each day for 2 weeks. A green pill costs 1 more than a pink pill, and Al's pills cost a total of $546 for the 2 weeks. How much does 1 green pill cost? So he has to take 1 green and 1 pink once a day for 2 weeks, so that's 14 days. And the total is $546 for the cost. And they tell you also that a green pill costs $1 more than a pink pill, like that. So we can put that into our formula for P. P would be basically G minus 1 times 14 is equal to 546. So this becomes 2G minus 1, and we have 546 divided by 14. 2G minus 1. 546 divided by 14 is 39. So 2G is equal to 40, and therefore G is equal to 20. So each pink, or what is it, green pill costs $20. So number 2, the answer is D. Rose fills each of the rectangular regions of her rectangular flower bed with a different type of flower. The lengths and feet of the rectangular regions in her flower bed are as shown in the figure. She plants 1 flower per square foot in each region. Asters cost $1, begonias $1.50, cannas $2, dahlias $2.50, Easters, lilies $3. What is the least possible cost in dollars for her garden? So the first thing we need to do for these regions, A, B, C, D, and E, we'll label them. So A, I'll call this one A, I'll call this one B, C, D, and E. Now A, B, C, D, and E, we have to figure out the areas. So for A, the area is just 4 times 5. For B, it's 3 times 7. C, 3 times 5. D is 1 times 6. And E, well, first we have to figure out the dimensions. So if this is 5 and this is 7, that means from here to here is 2. And similarly, if that's 3 and that's 1, then from here to here is 2. So that's just 4, 2 times 2. Now to get the least possible cost, we have to put the most expensive flowers in the smallest regions. That's how we're going to get the least. So the most expensive flower is $3. So put that in the smallest region. So put the $3 ones here. And then similarly, we put the next in line, that's $2.50, and the second smallest, so $2.50 goes here. And similarly, the $2 would go into the third smallest, $1.50 into the fourth smallest, and the cheapest flower in the remaining one, like that. And then now we figure out the cost, so it's basically the area times the price, so 20 times 1.5, the cost looks like 30. This cost is 21, 15 times 2 is 30, 6 times 2.5 is 15, and 4 times 3 is 12. Like that. So if you add up all these costs, you get 108. And 3, therefore, is A. Mo uses a mower to cut his rectangular 90 by 150 foot lawn. The swath he cuts is 28 inches wide, but he overlaps each cut by 4 inches to make sure that no grass is missed. He walks at a rate of 5,000 feet per hour while pushing the mower. Which of the following is closest to the number of hours it will take Mo to mow his lawn? So he's got this rectangular field, right? Like this. And then he's going to cut these swaths, they call it. And they're basically like that. There's the first one. And then he's going to slightly overlap. There's the second one, and so on. Like that. And basically, he has a dimension here of 90 by 150, and this is in feet, because they're mixing feet with inches here. And then each swath is 28 inches wide. So this first one is 28 inches. But then each one after that overlaps the other one by 4 inches. So you really only get 24 inches of new cut, right? Because 4 of those inches are overlapping the previous already cut portion. So each of these is 24, 24 like that. And if you convert these to feet, because this is in inches, this is 2, this is 2, this is approximately 2 1/3. So the number of swaths, or lines, or whatever, is basically 150 divided by 2 feet. You can kind of think of this as 2 because at the end they just want you to figure out the closest approximate value. So 150 divided by 2, if 150 is the full length and each swath is 2 feet, that's 75 swaths, correct? And then each time he goes and pushes his lawnmower to make this swath, he's going to walk 90 feet for each swath. So the total amount of distance that he walks is 75 times 90, which is 6,750 feet. And then finally, he walks at a rate of 5,000 feet per hour. So to figure out the number of hours, you would take the total number of feet and divide by 5,000 feet per hour, like that. And that looks like 1.35 hours. And that would be, for number 4, choice C. Many television screens are rectangles that are measured by the length of their diagonals. The ratio of the horizontal length to the height in a standard television screen is 4:3. The horizontal length of a 27-inch television screen is closest in inches to which of the following? So we've got a rectangular TV like this, and they're saying that the ratio of the horizontal length to the vertical length is 4:3, correct? And we all know, I hope all of us, every single person watching this video, that this is a 3-4-5 triangle. And even if you didn't know that, you can always use Pythagoras to figure that out, correct? So in our example, they're giving us a 27-inch TV, and that 27-inch represents the diagonal. So they're giving us 27 inches, and they want us to figure out what is the horizontal length of this guy. Well, it's a simple comparison. If this is, let's say, our L, 27 over L will be the same as 5/4. That's pretty much how you do this. So 27 times 4 is 108, 5L, and L would be 108 divided by 5, which is 21.6. So the horizontal length of this TV that has a diagonal of 27 is 21.6, and it's closest to D. The second and fourth terms of a geometric sequence are 2 and 6. Which of the following is a possible first term? So geometric sequences are of the form AR squared, AR to the power 3, so on, right? They tell you that the second one is equal to 2, and the fourth one is equal to 6, like that. And that's pretty much all they give you. They want you to figure out A. Okay, so where can we start here? Let's start with the ones that we are given the values for. AR cubed, AR, just R, and that's 6 over 2. So the A's cancel, and that gives you R squared is equal to 3. So therefore R is equal to the square root of 3 positive or the square root of 3 negative. All right? So now let's figure out A. I'll use this guy here. A times R is equal to 2. And first let's figure out what A will be if R is equal to positive root 3. So we have A times positive root 3 is equal to 2. So A is equal to 2 over root 3. Is any one of these answer choices 2 over root 3? And, well, let's rationalize the denominator first, because they always like doing that. 2 root 3 over 3. No, none of those. Okay, well, that leaves me with only one possible option, which is making R negative root 3. So negative root 3 like that. So therefore A is equal to 2 over negative root 3. Multiply top and bottom by root 3. And this gives you 2 root 3 over 3 negative. And yes, 6 is B. So there you have it. Penniless Pete's piggy bank has no pennies in it, but it has 100 coins, all nickels, dimes, and quarters, whose total value is $8.35. It does not necessarily contain coins of all three types. What is the difference between the largest and smallest number of dimes that could be in the bank? Those of you that are watching outside of the United States and Canada, a nickel is equal to 5 cents, or $0.5. A dime is equal to 10 cents, or $0.1, and a quarter is equal to 0.25 dollars, or 25 cents. So they're saying that the number of nickels, dimes, and quarters is 100. That's basically given in the question. And in terms of our dollar value, they've also given us that, $8.35. And that would essentially be 5 cents times each nickel, plus 10 cents times each dime, plus 25 cents times each quarter. And this actually will not equal 8.35. It will be 835 because I'm doing it all in cents. So I'll put that word in there. Cents. Yeah, just be careful there. And this was all in, I guess, dollars. Okay, so then what they're saying is you got to figure out dimes. What is the value of D? You got to figure out the largest value of D and the smallest value of D and then subtract them, the difference. Okay, so we've got 2 equations and 3 variables. Oh boy, so that means there's going to be some inspection involved. Okay, no problem. So I will call this one equation 1, I'll call this equation 2. So the first thing is I've got to get rid of at least one variable. And I think I can do that. First what I'll do is let me simplify number 2 here. Divide through by 5 and you'll get n plus 2d plus 5q. 835 divided by 5 will be 167. And then this will be a little bit more helpful. It's, simplified. So I think I can get rid of the n's just by subtracting those 2 equations. 2 minus 1 will help me get rid of at least one variable. So 2 minus 1 will give me n minus n, which is 0, 2d minus d, which is d, and then 5q minus q, which is 4q. And then 167 minus 100, which is, of course, 67. So here we go. I'll work with this now. If we have 0 quarters, let's say, if Q is equal to 0, that would mean D would equal 67. And therefore, that is the largest possible value for D. All right. So now let's find the smallest possible value for D. Okay, well, can D equal 0? If D equals 0, you'd get 4Q is equal to 67, and Q would therefore not be a integer, right? Q would be 16.75, and you can't have 16.75 quarters. Quarters have to be obviously an integer value, the number of quarters that you have. All right, D equals 1. That would mean 4Q is now equal to 66. And again, that's not going to give you an integer value. It's going to give you a number with a decimal in it, and you can't have 16.5 quarters. And if D equals 2, let's see, 4Q would then equal 65. And 65 divided by 4 is 16.25. Again, that won't work. How about D equals 3? Well, then 4Q would then equal 64, and Q would then be 16. So you get integer values, so that's good. So the smallest D is 3. And now they want the difference between the smallest and the largest. The largest is 67, the smallest value for D was 3, and the difference therefore is 64. So the answer here is 7 is D. Let that symbol x denote the sum of the digits of the positive integer x. For example, a club, I think. Club 8 is equal to 8. Club of 1, 2, 3 is the sum of the digits, so 1 plus 2 plus 3, which is 6. For how many two-digit values of x is the club of x equal to 3? So they are going to, I'll just use a star. It just makes it easier for me to write. How do you draw that club? Who knows? This operation on a number has got to give you 3. All right? So just on the side, very quickly, I want to explain what that means. So let's say my number is 99, my x. And I take the club or the star of 99. It's the sum of the digits, okay? That's the only thing that you really need to worry about. Sum of the digits of 99 is 9 plus 9, which is 18. Then what they're doing is they're doing it again. So they're doing this a second time. So like that. So the first time, this guy in here is 18. And then you do that again on 18. Sum of the digits of 18, which is 1 plus 8, is 9. So you see how that works? They're saying that you're going to do the same thing with some x, and the sum of those digits twice will be 3. Okay? So they only want x to be a two-digit number. So you're going to start with 10, 11, 12, and so on, all the way up to the largest two-digit number, which is 99. All right, now I'm not going to go through every single one, 10, and then 11, and then 12, and 13. I mean, that's going to take forever. But hopefully, very quickly, you'll see a pattern. If it's 10, the sum of the digits of 10 is 1. And then if you do it again, the sum of the digits of 1 is 1. With 11, the sum of the digits is 2. And if you do the operation again on 2, the sum of the digits is 2. 12, the sum of the digits is 3. If you do that operation again on 3, it's 3. So 12 is one of them. So if you can get a two-digit number that has a sum of the digits as 3, then it will work. So 21 works, 12 works as we just showed, 30 would work. Now after 30, the sum of the digits will never be 3 again. This is going to be 3, the sum of the digits, 3, and 3. But after the number 30, you can't get a two-digit number that has a sum of 3. But what about sums of 12? if you do the operation a second time on 12, it will be 3, right? And that's what we're doing. The operation is done twice. On the single digit 3, it becomes 3. The sum of the digits of 3 is just 3. But the sum of the digits of 12 is also 3. So now our task is to find 2-digit numbers, like 39, where the sum of the digits is 12. And we can easily do that. 48, 57, 66, 75, 84, and 93. And 99 is our final number, so we don't need to go beyond that. And I hope you're convinced that each of these, the sum of the digits, if you do it twice, is 3. So all of these will be the same. So how many did we get? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number 8, the answer is E. Let f be a linear function for which f at 6 minus f at 2 is 12. What is f at 12 minus f at 2? So if you have a linear function, it's basically of the form y is equal to mx plus b, like that. Or in our case, f at x is equal to mx plus b. So for example, if x is equal to 3, this would be f at 3 is equal to 3m plus b, correct? Substitute x equals 3. So very similarly, that one, f at 6 minus f at 2 is equal to 12, would be basically using this guy right here, our linear function, 6m plus b minus 2m plus b is equal to 12. So that becomes 4m, and the b's cancel, is equal to 12, and therefore m is equal to 3. So our function f at x is actually 3x plus b, since we figured out the value for m. Now let's turn our attention to that guy, f at 12 minus f at 2. So f at 12 looks like 3 times 12 plus b, and then f at 2 looks like 3 times 2 plus b, like that. So this is 36 plus b minus 6 minus b. So 36 plus 6 is, that's 36 minus 6 is 30. And the b's cancel. So I guess that's it. You're just left with 30. So this expression is equal to 30, and therefore number 9 is D. Several figures can be made by attaching 2 equilateral triangles to the regular pentagon ABCDE in 2 of the 5 positions shown. How many non-congruent figures can be constructed in this way? So only 2 equilateral triangles. They've put 5 of them, but only 2 we have to attach to the pentagon. All right, fine. Here's my first one. That's 1. And then here's my second one. Okay? And then here's my third one, but that one is the exact same as the one I drew previously. And here's my last one, and that is the exact same as the first one. So if you really think about it, there's only 2 unique ones that I created. Only 2 that were non-congruent. Okay? And that's really all they're asking for in this question. So the answer to number 10 is B.